Hi guys, so I'm Imran. I'm currently working in Cognizant as a associate project. So I do have a experience in machine learning also. So today we're gonna see about machine learning. Like how can we classify uh, uh, anything like an object using machine learning. So today I have taken an example with cat and dog. So we can classify it is a cat or dog using neural networks. So before starting, I'll tell an intro about the machine learning. What is machine learning? How it is working, and what are the types are available in machine learning? So that's what we are gonna see today. So I'll share my screen. So, like as I said before, today we're going to see about image classification with CNN. Before that, I'll tell how machine learning works and what is machine learning. Okay. So, machine learning is nothing but like we are teaching the machine to detect something or to predict something by training it with certain algorithms and feeding them with certain data. So that's how machine learning works. So Tamil okay or English? Anything? Kavita?
Um, I think today we have Regina Larpanga. I think English should be a better option because
Okay.
some people would have joined from other location as well.
Sure. Okay.
Yeah, thanks, Imran.
So, so like as I said, I'll tell you how machine learning works. So, like in machine learning, generally machine will understand only zeros and ones, right? So machine can't understand any strings or any images. It just understand zeros and ones. Like we need to feed them as a binary numbers. Okay. So then uh, how the machine is detecting the image? Like you can see, now we are having Google Lens or like chat GPT. Now it is trending like chat GPT. Like there are multiple tools that are using machine learning actually. So I'll tell you how, but we are like, for example, if you take chat GPT, we are
Imran,
giving the
sorry to interrupt you.
Mhm.
Headphones ஏதாவது இருக்கா? Like, can you use headphones? Because
Sure,
people
sure.
are saying little கொஞ்சம் சரியா
Clarity is
கேட்கலன்ற
okay.
மாதிரி.
Yes.
Okay, sure. Yeah, one second.
Yeah. Okay, Imranக்கு time கொடுக்கிற விதமா, like there's a lot of silence here, so I thought I'll ask one question. So அவர் வந்த பிறகு we'll அப்படியே wind up with few of us opening up. I think Imran is ready, right? Imran, can you talk now? Mute ல இருக்கீங்க.
Yeah. Can you hear me now? properly?
Yeah.
Yeah, okay. So sorry.
Okay, va, Makle? Is this fine now?
Kavita, let him speak. We'll see how it goes.
Okay, sir. Yes.
Let him. We'll observe for some more time.
Sure.
Okay, sure. So, like as I said before, machine will understand only binaries. Machines will understand only zeros and ones. But in case of like if you see ChatGPT, like we are feeding the data as a sentence, right? But how it understands our query and how it is replying. So that is where the step lies, like pre-processing. Okay, so the pre-processing is a step where we will convert the input into machine understandable thing. So let's see, like in our next session, we'll see detail about pre-processing and other steps. So today I'll teach you the basic machine learning things. So machine learning is nothing but we are training the machine to find something what we require. Okay, that is what we call it as a machine learning. So for this, we are using different types of algorithms like supervised, unsupervised, reinforcement, like that. There are three types of machine learning available. So I'll tell one by one. So like first we'll start with supervised learning. Supervised learning is nothing but uh, I know what I'm gonna predict or what would be the outcome. Okay, that is what we call as a supervised learning. So for example, uh, like for example, like in a basket, I know what I know the fruits. What are the fruits available in the basket? I do have a basket. In that basket, I am having 100 fruits. So the task is to classify. Like we need to separate the fruits based on the type of fruits. Then it is supervised learning because I know what are the fruits, what it's actually. Because like in the basket, it will have apple, orange, banana. Like I know what are the fruits available in the basket. I can separate it. So that is what supervised learning. Supervised learning is nothing but I know I will have the label. So based on the label, I will separate the things. I will find the things. Then it is a supervised learning. So unsupervised learning is nothing but I don't know what I'm going to find, but I will find based on the relation what I can see, like the same basket. But I don't know about the fruits. I don't know anything about the fruits. But I need to separate means how can we classify? Like we can visually see the colors difference between the each other. So like some of like I'm having for example I'm having two fruits. One is in a red color, another one is in orange color. So I can visually see the difference. Okay, this is red color, that is the orange color, and it is also in same round shape, but it color differs. So likewise, I will find the relationship between each data, and based on the relationship, I will separate the things. That is what we call as an unsupervised learning. I don't know what I'm going to find, but based on the data, I will group them. It is called we can call it as the unsupervised learning. And the last one is reinforcement learning. So reinforcement is nothing but I have trained the model, but it is predicting wrongly. It is not predicting correctly. Some of them are incorrect. Then, based on my comments, it is training another time and correcting the issues. It is fixing it's on its own based on the comments what we are giving. It is fixing everything on its own. So that is what we call as a reinforcement. For reinforcement, we can give an example like chess. If you play chess games in your mobile, first level it will be easy. Because we don't know the steps what we are gonna take. But on the next levels, it will improve its level based on the movements what we are doing. Based on it will like based on the levels, like the difficulty will increase, right? So that is the base concept of reinforcement learning. Okay. So in supervised learning, we do have two types. One is classification, another one is regression. Classification is nothing but like for example, I'm having thousands and thousands of data. Like I'm having a 1 lakh data, but though it is a 1 lakh data, I can group them by within a 10 types. I can categorize them within a 10 types or 12 types or any I can categorize them. then it is a classification. For example, I'm having 1 lakh people. So I can classify them based on the countries or heights or anything. Like if I classify them, there will be only 10 to 20 groups, right? Most maximum 10 to 20 groups only we can do. So these are all comes under classification. So based on the categorical data, we can classify something, we can predict something, means that is what we call as a classification. Regression is a different step. I know it will differ for each and every data. It will differ. For example, a person A is having 2 years of experience and he is having 5 lakh salary. Okay. So the person B is also having 2 years of experience, same qualification, but he is getting 6.7 LPA or something. Okay. So they both do have the same feature, but the output differs, right? The range, the salary differs, right? So how can we classify, so finding the common, the average value is called, we call it as a regression. So these both are comes under supervised learning. Supervised learning is nothing but I know what I'm going to find. So that is what supervised learning. So in case of unsupervised learning, we do have 2 types. One is clustering and another one is association. So clustering is like as I said before, the example, like in a basket, I'm having fruits. I don't know the fruits, but I can classify them. Like I can group them. Right? Uh, like for example, I'm having 10 people, so I don't know about them, but I need to separate them. I need to group them. Then how can we group them? Like based on heights, we can group them. They are tall, they are medium, they are short. So likewise we can group them, right? So based on the relationship between like relation and so many times I'm mentioning relationship is nothing but similarities between them. Similarities between them. Based on the similarities, I'm grouping them. That is what we call as a clustering. Association is nothing but have you heard about recommendation? Recommendation system. Anyone?
Yes, Netflix and all, they have no
Yeah.
recommended, right? So,
Yeah, recommend. We will like based on the series what we are seeing. Like for example, Uma is watching Money Heist. Okay, so likewise she is also watching like Breaking Bad. For example, I'm saying Breaking Bad or some other series. Okay, so likewise another person is also watching the Breaking Bad as well as Money Heist means. Like I can recommend them another series, right? So for Flash, I can recommend them Flash, like because Uma has the same seen same series. If you are interested, you can watch like this. So we are building a recommendation system, right? So that is what we call as the association. So association will see the relation between the data based on the like similarities. It will recommend the another feature. It will take the label on its own and it will recommend you can also watch this, you can also buy this. So that is what we call as the association. Okay. So these are all the levels of machine learning. But so we do have another type called deep learning, right? So why we need deep learning? So we already have machine learning, why we need deep learning? So it is nothing but uh, like I'm having a textual data. Textual data means like a data set. It will have only textual data. Means machine learning is a perfect thing. We can predict all the things within a machine learning itself. Most of the things within a machine learning itself. But in case of in visual things, image or computer vision or image things, means machine learning will also predict, but it will not have more accuracy. First, I'll tell about accuracy. Accuracy is nothing but like as I said, I will have a data. So I will feed the data to the machine. So that is what we call as a training data. So after training, it needs to predict. So we need to test like it is trained, but we don't know how much skills that model is having. Model is nothing but the trained algorithm is called it as a model. Okay. So I don't know what is the accuracy of the model. Right? like if I deploy it in the production, I don't know it will find my things or not. So we need to test it. So by testing the random data is what we call it as accuracy. By testing it, the random data and find the accuracy, we already know, like we know these are things, but if I feed it to machine, I need to find what machine returns. Then I will compare the output of the machine and the actual data. By comparing, I will get a percentage. So that is what we call as accuracy. So based on the accuracy only, we can deploy the model in the production or not. We need to decide. For example, a person employee is working, but when he done a code, when he created a code, like there's a 50% bugs, there's a 50% errors means we will take action because he is not performing well. Because if he's having 50% bugs means he's lagging something, right? So that is accuracy of that person, that employee. So but another employee is doing code, but the bugs are minimal. So then we can improve, like we can sort it out. So these are the bugs, it is a normal, so we can put it on a new project. So we do have confidence, right? Likewise, in a model also we need to check the accuracy, and if accuracy is less means we need to retrain it, or we need to find what lacks in training, or what is lagging, so that are all different part. Because to improvise algorithm, to improvise the accuracy, we have bagging, boosting, or overfitting, underfitting. These are the problem arises, but generally we need to check the accuracy. Okay. But in case of accuracy, machine learning will perform well in textual data, but in image-based data, machine learning will not have that much accuracy. So that's where the deep learning comes. So deep learning is nothing but one part of machine learning, but it will analyze the data more and more and get the features more. So based on the feature only, it is finding. So I'll explain the CNN so that you may understand how it works. Can you hear me now properly?
Yeah, little better, like, I know.
Sorry.
Like some echoing coming, no, with your voice.
Actually, I'm in an empty room, so due to it, it's going.
Okay.
Now it's okay.
Yeah.
Yeah, go ahead. You go ahead.
Yep.
Listen.
Yeah. Okay. So, like the CNN is one of the neural networks available. So CNN is a convolutional neural network. So, like deep learning is nothing but it is also machine learning, but it will have different types of layers, and based on the layers, it will find the features correctly. It will analyze the data correctly, and it will find more features. Features is nothing but that are all the keys to find the details. So, like what we are finding, like we are predicting something, right? So if I want to predict something, it should analyze the data detailedly, right? So that is what we call as the features. So in machine learning, it is also analyze, but it will not that much deeply analyze the more data and find the feature. But in case of deep learning, it will analyze the inputs and find the more features about the input, and based on the features only, we can able to classify them. Okay. So CNN is one of the deep learning algorithm we are gonna use today. Okay. So first, check the slides. So the CNN or deep learning model suited for online, like as I told before, for visual, like for finding something image based means the CNN will suits well. And then the basically neural networks are uh, like they are discovered based on the human activities. Like you heard about neurons, right? Neurons. So there are a number of neurons. From that n number of, like if I see something, our brain will comment that, like actually how it works is the neuron. There are a number of neurons available in our brain, and based on the thing only, it will find the feature, and it will tell the brain this is the shape. So based on the like, actually the neural networks is found based on the human activities only. So if I see something new, I will not actually I'm going to a new place. I haven't seen it, right? But when I comes another time, I will able to find because I already see it. So our brain will reach that. Likewise, the neural networks will analyze the data. Initially, it will not know, but it will capture all the features from the input, and it will store. On the next time, if the same image or same thing or similar thing arises, okay, it seems like this thing, so we already find it, so we are assigning to this label, this output. Okay, we are assuming, okay, this is a dog, this is a cat. Based on the previous data only, it is identified. So this is same thing like what humans work, human things. So that's how they build a CNN. Not only CNN, all the neural networks are based on these activities only. So let's see, how do computers see? For computer, an image is just an array of values. As I said before, computer machine will understand only the binaries, the numbers. Okay, it will not understand any alphabets or anything. It just understand the numbers. So if I pass an image, it seems like a set of arrays of values and numbers. Okay, so it typically have three-dimensional. So you heard about RGB, right? So red, green, blue. So like every zero is a black, and 255 is a white. So in between the values will differ. So based on the in between values, it will have red will have 50 or 60, or blue will have 70. Like wise, it will create three matrix that will have red blue value based on the image color. For example, if I take my image, I'm having yellow, right? So yellow will have a separate red value. So mixture of yellow and I think green or red and okay. So red and blue, it will create yellow. Okay. So based on the red and blue values only, we will these are the primary colors to get an image, okay, get a color. So every image will have red, blue, green values in nature. So based on the image, it will assign the values to the values to the image matrix, and then hello, can you hear me?
Yes, yes,
Yeah,
yes. Go ahead.
So based on the matrix value only, it will find the pixel values, and it will align arrays. Okay. So whereas each pixel have a specific value of red, green, blue represent the color of the given pixel, but this is just an input of visual recognition. So it's just a input image what we have given. Okay. So the CNN process the images using matrix weights called features. Okay. So it will apply matrix calculation and find the features. So first I'll explain the layers. There are multiple layers available in CNN. So these are the layers required to build a CNN. So input layer where you will pass the input data, and then convolutional layer where it will find the initial level of the features of the input. If I pass a cat image, it will convert the cat image to a feature map where it will have basic features, not all the features, but it will find the basic feature of the image, and then one by one it will find finite finite input that will have only features, so that on the next time it will find the similarities between the images. So these are the layers that required to build a CNN: input layer, convolutional layer, activation layer, coding layer, and fully connected. So input layer is just three-dimensional matrix where it will have width, height, and channels. Channel is nothing but so you can see, right. So it is a 32. Like all images should have the same width, same height, and the channel is nothing but red, blue, green. So the channels are red, blue, green. The three-dimensional arrays. So that is what the channels vectors. So So this is how the input layers should be. Then in the convolutional layer, we will play the this convolutional matrix to our actual matrix get from the image. So for example, this is my matrix available from the image. It will multiply this matrix one by one, and it will create a 3 cross 3 matrix by summing up the total value. For example, like 1 minus 2 1 0 0 0 1 2 1. But in case of by multiplication, it will assume this as a 1, not a negative value. In case it will apply, it will convert all the values into positive values. Okay, so here one right. So actually, this matrix is wrong. It is actually 1 0 1 0 1 0 0 0. Likewise, it has to be. But I have in case of emergency, I have taken this GAF. Okay, so this is the actual convolution matrix. So while applying the actual matrix into this convolution matrix, we will get the a 3 cross 3 matrix. Like for example, I have taken 3 cross 3 matrix, but actually it will have the phasor based on the matrix size and width. So it will create a feature map. So the purpose of the convolutional layer is to create a feature map to my input. Okay. So after creating a feature map, what happens is it will apply the feature map into activation layer. So where it will convert all the negative values into zeros. So return 0 for every negative values and input images while return the same value. So if it is a positive value, means it will return the same value. If it's having a negative value, it will return a 0. So actually, so this is the actual output of the activation layer, I think, because while multiplying with -1, it will give -1. So due to it's a negative, it will convert into 0. So if I'm one second. Okay. So, so I will multiply this matrix with this matrix. So -1 into 1 is -1. So plus 1 into 0 is 0. 1 into 1 is 1. Plus 1. And then 0 into 2 minus 2 is 0. 0 into 1 is 0. 2 into 1 is 2. So that's 2. And then 0 into -1 is 0. 0 into 0 is 0. 1 into 1 is 1. So while applying the activation layer, this minus value is converted to 0. So while summing up, it will return as the 4. So that's how this feature map has been created. So likewise, it will multiply all the values of the convolutional matrix and give you the feature map. So that is how it is created. So I'll move on to next session. After the activation layer, it will go to the pooling layer, where it will minimize the feature map into a 2 into 2 cross matrix, like not 2 into 2 cross. Based on the matrix dimension, it will minimize the matrix dimension. So in case it is a 4 into 4 dimension, right? So if it is 4 into 4 means it will minimize into 2 into 2. So likewise, by summing up all the by getting not summing up, by getting the maximum value from the given feature. So in case of this cube, this 2 by 2 cross, like here 6 is the maximum value, so it will take 6, and then in this case 8 is the maximum. So likewise it will go on to all the feature, and it will get only the maximum value from the feature. Maximum is the uh, feature that have more darker or more shape, like edges are clear. So that's how it is taking the maximum point, so that if I apply the normal feature map, I will get less accuracy. But while applying the maximum point, I will get more accuracy. So likewise, I will have the pooling layer, convolutional layer, like convolutional layer, pooling layer. Then another convolutional layer, then pooling. Likewise, I will get the finite features. So from this image, I will convert to this feature map. So I will minimize all the features, and I will have only the better, like good features or not. I will omit the feature that is not having clear thing or less accuracy. So I will get only the maximum features. So from this maximum features, I will connect with the fully connected layer, where it will convert all the things into nodes. I will show an example. So this is how the input will come, and from this input it will convert. It will apply the convolution layer, then pooling. Likewise, after getting the max pooling, it will convert the output into multiple nodes, n number of nodes. By applying the flattened layer, it will convert all the features into n number of nodes. So I'm having the labels, right? Label is nothing but, for example, dog, cat, or car. So this is the image. This is dog image. This is cat image. Likewise, I will have the train data. So I'll show the data. So for example, let's take this. So this is the cat image. So my label is nothing but the file name is my label. So likewise, I will train my model based on the labeling. So I will have the label as well as the features. So this is what we call as a label. So these are the labels, and these are the features what we get from the after applying all convolution, pooling, and activation layers. We will get the nodes. So it will connect the like I will have multiple images, right? For example, in the cat image itself are hundreds or thousands of images I'm having. So it will refer to only one class. For example, this is a cat label means. So this is called the cat image means it will also refer to the same class. So this will also refer to the same class. Likewise, it will now have the features as well as labels. Now, if I apply into the the algorithm, what happens is it will check the similar relationship between this image and this node, and this node into this node. So likewise, it will analyze the feature, and then if I pass a non-trained data, it will check the same relationship in that image, and it will find the class. Class is nothing but the output. It is a cat or dog. So that's how the convolutional convolutional neural network will work. Actually, I haven't asked any doubts. Like, do you have any doubts? Like in between, I have taken, right? Did you understand how it works?
Team, any doubts?
No, Kavita.
Yeah. Thank you, Ma.
So actually, today we have seen theory of the convolutional neural network, but tomorrow we will see how actually it works in a coding. Like, I will not gonna explain all the things, but I'm gonna apply the train data, these images. I'm gonna train the model, and I'm gonna predict. Like, if I apply a new image, I will pass a new image. It will find these are all dogs, these are all cats. So that is the agenda for next session.
Okay. Thank you, Imran. Thank you so much for today. So guys, so tomorrow we are going to look at the details of like the code behind the classification, image classification.